Dear students, we are going to see the solution of questions asked in the internal evaluation 2. One by one, we will see all the solutions. So let's take the first question asked. So in this question, the function f of xy is given, that is y upon sine y for y is not equals to 0 and 1 for y is equals to 0. So in that case, we need to find evaluate this integration for x is equals to 0 to 1 and integration for y is equals to sine inverse x pi by 2 f of xy d by dx. F of xy will be treated in such a manner. Here the two partition are given according to y. It is free from x. So let us see first see the domain over which we have to integrate or we have to evaluate this double integral. So we have this integral is given, so f of x y that we have kept here y upon sine y. Now we change the order of integration. So before changing the order of integration, let's see the region of integration. So here what we can see, the y is equals to sine inverse x, so that can be written as x is equals to sine y, and here y is equals to pi by 2. So y is equals to sine inverse x that we have plotted in such a way here, and y is equals to pi by 2 that will be plotted here, this point. X is equals to 0, that is the y-axis, and x is equals to 1, so this point is the point of intersection here. So under this area we have to integrate or we have to evaluate this integral using double integration. So by change of the order of integration that we will do, so we keep this figure here. So this integral will be equals to, first we take x, so x will vary from x is equals to 0 to x is equals to 0 to x is equals to sine y at this point, and this point. So y will move from 0 to pi by 2. So y is equals to 0 here and it will be pi by 2 that we can take. So y sine y is remains same. So by having this, what we do, first we integrate with respect to x. So it is integration simple x limit 0 to sine y that we put here. So by putting this value, what we get, sine y and sine y will be cancelled. So only y will be there. So it will be integration of y dy, keeping the limit y is equals to 0 to pi by 2. So after integration, it is y square by 2. So limit is 0 to pi by 2 and your answer will be pi square by 8. So in this way we get the solution. So y 0 to pi by 2 that we have taken here, 0 to pi by 2, and x from 0 to what, this sine y. So your integration over this continuous line. So that we have to keep in our mind before putting the limit. Okay, so you can match your answer what you have given here. Now the second question, this is the second part of question 1. It is what, again it is a double integration 0 to 2 and integration y by 2 to y plus 4 by 2, and your f of xy is what, y cube 2x minus y e to the power 2x minus y whole square dx dy, and the transformation is given here, u is equals to 2x minus y and b is equals to y. So it is a change of variable that we have to operate in this question. So first we sketch the region again to understand how the region is moving. So by default, the functions are given in the form of y, so the limit will be x is equals to y by 2 and x is equals to y plus 4 by 2. So this can be written as what? 2x is equals to y. So what we have, okay, and this can be written as what? 2x minus 4 is equals to y, that we can write that equation, or you can write 2x plus y is equals to 2x minus y is equals to 4. That can be also written here. So x-axis and y-axis we have taken x, y, origin. Now first we draw here what? 2x is equals to y. So this line that we get. Second is what? 2x minus y is equals to 4, or 2x is equals to y plus 4, that we can write. So it is a what? It is just extension of the y is equals to 2x, shifting, that we can say. Now we come to the next limit, which is y0 and y is equals to 2. So y is equals to 0 is the x-axis that we see here, and y is equals to 2 that we have taken here. So the area over the area or region over the integration need to be performed initially. So this area that we get. But the thing is, we have to operate the what? Change of variable. So while for change of variable, what we have here, okay, these points are we have taken here. This is what? For y is equals to 0 at this point. So x will be 2, not 4. And for x is equals to 0, so this line will be y is equals to 2, that we can get here. Okay. Now by change the order of integration. So first I keep this figure as it is. So the transformation is given y is equals to 2x minus y, b is equals to y. What we do, we change the region of integration from xy to uv plane. So xy to uv plane, so what we get here, for y is equals to 0, for y is equals to 0, v will be what? Also 0 under this condition. Y is equals to 2, so v is also 2. Now y is equals to 2x, this along this line. So what we have, v is equals to x is what? 2x will be u plus y. So b is equals to u plus y, and y is also v, so that we kept u plus b. So ultimately what we get here, b is equals to u plus b, so u is equals to 0, that we get as a first. Okay. Now the second is y is equals to 2x minus 4. So what we get here, y is equals to 2x minus 4. So we keep here y is equals to v, and 2x is what again? U plus y, and y is also v. So in that case, the next line that we get, u is equals to 4. So that 4 is written for u. Okay, so next part is, after having this limit, we will draw the next region over the over that region we have to integrate. So this is your xy plane, this is by xy plane, and that you are transforming in the form of uv plane. So what we get here under this transformation, which kind of region what we get, this is the u and v axis. So first we draw v0, sorry, u0, then it is u is equals to 4, this is v0, and this is v is equals to 4. So over this region we have to what? Integrate. So this kind of figure will be transformed in such a way. Next thing is, when we use the change of variable, we perform the double or triple integration by changing the variable or changing the region of integration, we require the Jacobian. So in next part, what we do, we will apply the Jacobian. So Jacobian will be what? X by 2ub you are transforming. So Jacobian will be del x upon del u, del x upon del b, del y upon del u, del y upon del u. And by performing here, what we get, x del x upon del u is 1 by 2, it is 1 by 2. Finally, Jacobian is 1 by 2. That you can check from your solution. U is what? It is 2x minus y and b is y. So for del y upon del u it is 0, del y upon del v it is 1. Now for del u upon del x, if you perform del u upon del x, so it will be what? Okay, y is equals to v you can put. So 2x is equals to u plus v, or x is equals to u plus v by 2, that you can take. So from there you can write del x upon del u is 1 by 2, del x upon del v is also 1 by 2. And final, the determinant of this matrix is 1 by 2. So your Jacobian is 1 by 2 that you get. Now, after performing this, so Jacobian is J is 1 by 2. So what we can write? Dx dy is equals to 1 by 2 du dv. Here you can see the application of Jacobian as well. So earlier what we had the figure in xy, it's half of the region 1 by 2 that you del u del y v, it is 1 by 2 del u del v that you get here. So area is bigger now, but over the integration it is a finite integration that you will get. So earlier that was your question. Now the limit will be for u it is 0 to 4 and for v it is 0 to 2 that you perform. 1 by 2 is the Jacobian. It is y cube here, so it is v cube. 2x minus y, it is u e to the power 2x minus y square, so it is e to the power u square that we will perform. So again, it is the separate of separate variable. You can also separate here 1 by 2. So first we perform for u. So it is u e to the power u square. You can keep u square is equals to what? You can keep u square is equals to like t. So 2u du will be what? Dt. So u du will be 1 by 2 dt, and limit will be what? Limit will be for u is equals to 0, t will be 0. For u is equals to 4, so t is equals to u square, so t will be 16. So limit will be what? 0 to 16 that we will perform. So this is your limit 0, 4, 0, 16. So what we get here over that, it will be 1 by 2 into 1 by 2, 0 to 2, this 1 by 2 for that what we get here, and it is 0 to 16 e to the power t dt that we get, and v cube will be outside, v cube dv that we perform. So ultimately it is what? It is going to be 1 by 4, 0 to 2, and v cube that you can put here e to the power t 0 to 16 dv. So that we have applied, it is e to the power 16 minus 1 v cube dv, and it is 1 by 4. So this is the constant that you can take outside, and you perform only for this one. So what we get for this one, 0 to 2 v cube dv. So it will be what? V to the power 4 by 4 0 to 2. So no issue with the lower limit 0. So it will be what? 2 to the power 4 upon 4. So what we get? It is 4. And 1 by 4 is there. So that will be cancelled and you will get only e to the power 16 minus 1. That we get as an answer. So I hope so. The first question is clear, that you understood here. So in next, we will talk about the second question. So thank you for watching this solution. So you can like this video, share this video with your friends, colleagues, those who have given the examination, and you can subscribe my channel if you have not subscribed yet, and you can comment on the comment box about this video. So once again, thank you for watching this video.